This is the screencast for section 3.9, example 7, logarithmic differentiation. Yeah, I know, we've been doing logs for a while now. Okay, wait, but look at this one. Find the derivative for y equals x to the x, really? U to the u? Are you kidding? And it says x is greater than 0. So first of all, what does x to the x even look like? Well, technically, the domain for x to the x is all real numbers. You can see I've typed in x to the x and I found some various negative values. It's just very, very discontinuous because a negative, number to an even or a negative number to an odd, and then you got all those decimals in there. It's a whole big mess. So instead, they're like, just worry about x is greater than 0. Good for us. Now, the problem is y equals x to the x. I don't know how to take that derivative. I don't have a formula for u to the u. Well, this is one of those problems where you might not see the answer right away, so we got to try a couple things. Is there a way we can separate the base and the exponent? Because those are both u's. I can't take the derivative of both of them at the same time. Well, yes, logs. So I'm going to take the natural log of both sides. So I have the natural log of y equals, and then the natural log of x to the x. Now this x can become a coefficient because of my log properties. I know you may not have thought of that right away, but hopefully eventually you would come around to it. Okay, natural log, let's see, now I'm going to take the derivative of both sides. So now the natural log of y is, yes, 1 over y, and don't forget that will also be dy dx in there because of implicit differentiation. Now I can use the product rule on the right side. 1 times the natural log of x plus x times 1 over x. So now I have, let's see, 1 over y dy dx equals the natural log of x and then plus 1. Multiply both sides by y, but I'm not actually done yet because I know what y equals as just an expression of x, so I can substitute that back in at the end, and dy dx equals x to the x times the natural log of x plus 1. That wasn't so bad. The now try problem number 43 actually gives us a hint. It says use the technique of logarithmic differentiation to find dy dx. So I can already tell right off the bat that I'm going to take the natural log of both sides, and then that will make x a coefficient. And now I can take the derivative of both sides of this equation, use the product rule on the right hand side. And when I'm taking the derivative of the natural log of sine of x, I have to remember that is the natural log of u, so I need to multiply by then the derivative of u, which is cosine of x. Simplify my product rule on the right, and now multiply both sides by y to get dy dx by itself. And substitute back in the original expression for y so that I have my derivative all in terms of x. My answer is complicated, but as long as you remember the logarithmic step at the beginning, should be pretty straightforward, just messy.